Hey everyone. So in this video, we are going to try and give you an overview of what RAG is. It's a term that you're probably familiar of in the context of LLMs or large language models. So let's do a quick dive. So RAG stands for Retrieval Augmented Generation. What does this mean? Well, generation, as we know, is related to the LLM or large language model that's capable of generating text. And by retrieval, what we're saying, or retrieval augmented rather, is you give a query to an LLM to get a response. But now what you're trying to do is augment that query with information from a knowledge base so that the LLM can give you a better answer. So let's look at an example and this should become clear. So we have this LLM, which as we know is basically complex neural network. Let's say we ask it a query, how many goals has CR7, which is Cristiano Ronaldo that most of you are familiar with, how many goals has he scored? Right? And say we ask this question to an LLM, let's say ChatGPT. What is the response you'll get? Well, let's actually go try this out and see what we get. So let's ask ChatGPT the question, how many goals has CR7 scored? Don't use any sources or search. What does it do? So it tells you that based on early knowledge, it's got this answer. Now, why does it say that? Well, when you ask it the question, what it's effectively doing, as you can see here, is it's going to take the query and then pass it through the neural network, which is what ChatGPT is, right? It's a large language model. And the information obtained is basically a mathematical calculation, right? Based on the parameters of the neural network, which are dependent on what it's trained on. And models like these are very hard to train, take a very long time, very costly, so not trained all the time, right, on the latest available information. What this model will have is an information cutoff. In this case, you can say it believes it has information, or it has been trained on information around early 2024, right? Might have been trained for later, but anyway, in this case, it's telling you that it's been, based on 2024, this is the answer, right? And that's because that's probably around the time, that the model has been trained or fine-tuned or whatever. And so that's the knowledge cutoff of this model. If you wanted to give you a better response, then you need a way to augment or supplement to this knowledge base and give that extra information or access to the extra information to ChatGPT in this case, and then it can give you a better response, right? Because at the end of the day, an LLM is just a language model. It's just good at predicting the next set of words given the context. So let's give that a shot. What I'm going to do is go to Wikipedia and I'm going to look at Cristiano Ronaldo. Now, you see this first paragraph has some statistics. So what we're going to do is, let's just feed this to ChatGPT, ask it to answer our question again. Okay, so let's copy this. So now we're back to asking the same question, how many goals has CR7 scored? Use the information I am providing. And then I give it the information and I hit go. Not formatted in the best possible way, but you can see. So now it goes, well, Wikipedia says, or the article says 900. So ChatGPT now gives you the information based on that, right? It also gives you the numbers you see here: 140 goals, 14 goals in the European Championship, and so on, right? So it's able to now use the reference and give you the answer. Now, if you want to do even better, you can ask the same question: how many goals has CR7 scored? You can use the web, right? So you're giving it access to better sources. It now goes and searches, and now what it's able to do is give you a much higher, more accurate answer. So it says as of May 2025, Cristiano Ronaldo has scored 934 goals. It's got a much better breakdown and it's got sources. So you see how as ChatGPT, which is an LLM, has access to more and more information, it's able to give you a response that's a lot more accurate. Okay, so let's now get back to the slide and quickly review what we've just seen when we use ChatGPT. What happened when we just asked it to use no resources, right? So the text or the query we have asked goes in the form of a prompt, right? The instruction is asking the LLM to give you a response. The LLM gives you a response and says he has scored a certain number of goals. Now, the problem here is that the answer is not accurate because Cristiano is still playing, right? Now, the LLM, unfortunately, has a knowledge cutoff, right? There is a certain amount of data on which it's trained. And in this case, let's say it's 2024, it does not know the latest information, right? And so it gives you an answer based on the information it has. Now, in our case, it did tell us that it only has information till 2024, but all LLMs might not tell you that. It'll just give you an answer and you might believe it's the right answer. So the knowledge cutoff, which is basically the time at which the information, or the data on it was based on, or just the data it's been trained on, if it does not have the answer, it might not tell you it does not have the answer. Instead, it would do what is called hallucination, which is it would just create an answer and the answer would look very convincing, right? However, it would be wrong. And so that is where the concept of retrieval augmented generation comes in. So what you do first is you take your information and you store it in what is called a vector store. Effectively, you're creating a knowledge base, right? So you can break this information down into chunks because you don't want an entire document to be extracted and fed to the LLM, right? LLMs have context windows. So there's a limit to how much information you can give. So you break this information down into chunks, convert them into what are called vectors, and store this in a vector store. And now that you have a knowledge base, so in this case, let's say we store all the information available on football games and football players and so on, right? So now when this query is asked, it's first routed to the knowledge base. The LLM can do it itself, or ideally in the RAG pipeline, the query goes in, and then based on the query, the relevant pieces of information are extracted. These are then added to the prompt. So the prompt now becomes the query and the instruction plus any relevant pieces of knowledge, and that is then fed into the LLM. And the LLM now, as we have seen, will use that information to give you a response. And that response now is the most relevant response. Now, in this case, the problem we had was Cristiano Ronaldo has been playing, even now is an active football player, and the information the model had or was trained on was from last year. So it does not have a latest count, but it could be information that the model does not have at all, right? And so because it's not been trained on that data. And so that is where a RAG framework comes in, where it can allow you to now, get the right answer from the LLM. What it also does is you do not have to have an LLM trained on the latest amount of data, right? Because LLMs are extremely difficult, time consuming, and costly to train, especially with large, models like ChatGPT, which have trillions of parameters, right? So you can't keep training or fine tuning them. Knowledge base, however, can be updated very easily. You have more information, you update the knowledge base, and now you use RAG and the LLM can give you a response. So the basic idea of RAG is it makes it, because LLMs are very costly to fine tune or train, what RAG can do is improve the accuracy of responses by reducing hallucinations, by giving it the information or the relevant information from your knowledge base. And what it also allows you to do then is build, LLM apps on your proprietary data. So you have proprietary files and you want, you want to extract information, and LLM can help you with that by, if you can set up a RAG pipeline and then use the LLM along with the relevant chunks of information and get the information extracted in a form, in a useful format. So that is where, RAG apps become extremely useful. And then this then gets extended to what are now called agentic systems, which we'll cover in a different video. So hopefully this has given you an understanding of what RAG is. At some point, we'll build a full RAG pipeline, but hopefully this should give you enough to get you started, or at least when you read about RAG, you have an understanding. Okay? See you in the next one.